Hello, everyone, and welcome to another episode with your girl, Audrey Codner from ACG Math Tutoring. So hopefully you guys are doing well tonight, this afternoon, maybe even this morning, wherever you're from. So what we're going to work on today is the quadratic formula. Okay, we're still going forward with our factoring. So we're working on that quadratic formula. Let me zoom in so I can help you figure out what is the quadratic formula. So the quadratic formula is another way for you to find your value for x, those x-intercepts, all right? So what we're doing is we're going to take negative our b value, plus or minus the square root of b squared minus 4ac all over 2a. So, hey Jackie, hey Ray, hey Marilyn, welcome on in. Thank you so much for guys coming on in. So, we have done factoring when you have your leading coefficient is 1 and when it's not 1. But sometimes when you try to do the whole cross and all of a sudden you get to a point where you can't find the two numbers, what two numbers multiply will give me my AC and what number will give me my B. And sometimes it doesn't come up so easily. So this is why we use the quadratic formula. Now, some people will just say, you know what, I just go straight to the quadratic formula anytime I do factoring because this can help you graph anything or it can help you break down anything. So let's go with our first example. So our first example is 4x squared minus 12x plus 9 equals 0. Okay? So the quadratic formula works well when you're dealing with an equation because we're trying to find our x value. So if I may, when we look at this, this is in what's called standard form. So standard form is your ax squared plus your bx plus your c equals 0. So your a is always the coefficient of the x squared. Your b, including its sign, is going to be the coefficient of the x, and the c is going to be the constant. So all we're basically doing is one, let's label what our a and our b and our c is. So it makes it a little bit easier for us to plug it into the formula. Okay, don't know Jack. Here we go. So if we got our 4, we have our negative 12, and we have our 9. So the A is 4, B is negative 12, and our C is 9. So all we're doing is plugging it into our formula. So we have our x equals, we have our negative, we're going to put in our B, plus or minus the square root of our b squared. Let's see if I unzoom just a hair and shift, minus our 4ac all over 2 times a. Okay, so this is the reason why, hey Gen X Todd, thank you. So this is the reason why I put parentheses, because this first step gets everybody each and every time, all right? So when I plug in, this is supposed to be my B. My B is a negative 12. So I put in the negative 12. What a lot of people generally do, if I didn't put a parenthesis here, they would put 12. They won't make it into a negative 12 because they think that they are substituting they think that they're substituting their b for this whole entire section. No, you're only replacing the b. So that negative is going to stay outside until you have to do some kind of operation to change it. So when we take a look, negative 12 goes here as well. My a is 4. My c is 9. And my a is 4. So we're basically plugging in the b values twice. We're plugging in the a values twice, and we're only plugging the c value once. All right. So, yes, how are you? So now we're actually going to start simplifying. So let me extend up. So we have a negative times a negative 12. So that means we are dealing with a positive 12. Plus or minus square root. Negative 12 squared. That means negative 12 times negative 12. So that's going to give me a positive 144. Now here we have a negative 4, a positive 4, and a positive 9. So this minus sign is acting as a negative for that blue 4. So when I do this, I got negative 4 times 4, which gives me a negative 16. And then negative 16 times 9 gives me a negative 144. All of this is going to be over 2 times 4, which gives me 8. And don't forget about the x equals, because we're doing this to find our x-intercepts, aka our roots, aka our zeros, aka our solutions. All right? So now, with this, let's work what's going on underneath that square root. So here, we're going to have our x equals. We have our positive 12 plus or minus the square root of 0. Because 144 minus 144 gives me 0. Divided by 8. So, square root of 0. All right, thank you guys so much for the follows. So square root of 0, that is going to give me a 0. So that means I have 12 plus or minus 0 over 8. Now, 0 is a placeholder because 0 is neither positive nor negative. So we're actually seeing there's two solutions, but let me show you what's happening. So now let's simplify this way. 12 plus 0 and 12 minus 0, no matter what, you're still going to get 12. Now you got 12 over 8. Now 12 eighths can be reduced. Okay? What they both have in common, yes, is 2, but 4 is so much better. Okay? So now we have 12 divided by 4, that gives me 3. And we have 8 divided by 4, which gives me 2. So we're looking at my x-intercept being at 3/2. And I know there's some people out there like, can we change it to a mixed number? Guys, it doesn't matter because you're going to be looking at it as a graph. Why is root 0 equal to 0? Anything 0 squared, that's 0 times 0, that will give you 0. Okay, hey Jose. Okay, so we're not doing completing the square tonight. We're just doing quadratic formula. Okay, all right. So if I may, from the very beginning, we started off with the 4x squared. This should tell me how many solutions I'm going to have. I'm supposed to have 2 solutions, but we end up with 1. So when you get something like this, especially when you're adding, subtracting to a 0, you have what's called a double 0. So a double 0, let me see if I can sketch the graph like right here. If I did a quick sketch, say that's 1, that's 2, so it will cross there. It's basically going to kiss. Your parabola is just going to kiss your x-axis. It's not going to cross. Okay? So if you ever get an answer that's just one answer after you did everything, that means that graph is basically going to bounce off, or I like to say kiss, the x-axis. So when it kiss, when you're kissing, you usually kiss with 2 lips, right? I hope not. I hope so. Not weird all animalistic and stuff. Okay, so you're using 2 lips. So that means this, when it hits or bounces off the x-axis, is considered a double 0. So it counts for 2 solutions. Okay? I know. All right, awesome. Mind over matter, good job. All right. I know there is something else here. What's going on here? This math makes me cry every day in school. I always told myself I'm stupid because I don't know this stuff. Mind over matter, please. You just didn't have anyone that kind of helps push a little bit. Okay? You're not stupid. Remember, we all learn at different rates. Okay? I know when I was first introduced to all this, trust me, I wasn't ready. I keep telling you guys over and over again that I used to suck at math. Like hardcore suckage. Like there was no return whatsoever. Okay? But it takes practice. It actually took a teacher that literally said to me, division or fractions is nothing but division. And I was like, say what? Once she said that, for some reason, it just clicked. You never know when this stuff clicks. Because I was at the rightful age of 25. And all of a sudden I'm like, oh, that's why we do, right? All of that stuff. All right. See, and that's the thing. Here's the thing. Some people are really good at algebra. Some people are really good at geometry. Some people are really good at calculus. Because maybe it's like, oh, all that crazy stuff that we used to do in algebra, now I see how it's connected to something bigger. So my thing is never give up. Because you never know when all this is going to click. And it's going to take time. All right? It's definitely going to take time. All right, so before we get into anything, let's find our A, our B, and our C. Okay. I was put in basic math until 10th grade. The teacher says you're going to learn algebra. Yeah. And you know what? The fact that it was just you had that person that just says, I don't want you to be a part of the system. There's so many students that I went to bat for IEP meetings and they're like, oh, all you have to do is teach them this and that's it. Or they're just in their class just for the exposure. And I'm like, say what? No, you're in my class to show me, can you break down? Right? Yeah. And it is. It's a little challenging because we all have to be in that mindset. It's different now that you don't have to worry about passing a class. Now it's just, let me do some math. Let me see how chill this is, right? Miss Kick Butt, there were so many holes in my education that I had to start in remedial math in college. Yeah, trust me, I know a lot of students that supposedly graduate from high school, and yeah, they were just passed along, unfortunately. Hello, David. Oh, my day has been really busy. In your GED class now? Good, Jazzy. Good. I'm doing all right. How are you, David? All right. Made you understand it. Exactly. Okay, now they pre-test your math aptitude. True. And then it makes you feel some type of way. All right. Well, let's do some math. We can do this. So remember, your A is the number in front of the x squared. Your B is in front of the x. And your C is your constant. So that's telling me my A is 2. My B is 15. And my C is 28. Okay. I'm just learning this right now. So A times C, that's the AC method. We're going to do the quadratic formula. Okay? So we're going to do the quadratic. Something like happens and the formula pops in your head. I can solve that. Good. All right, awesome. So now let's take a look. The formula, so we got our x equals, it's our negative b plus or minus our square root of our b squared minus 4ac all over 2a. Okay, so if you're wondering what is the formula, let me kind of put it off to the side. Right, I'll stick it right here. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what we're doing is we're trying to find the x-intercepts. Okay, so this is the formula that we're using. I like to put in parentheses because we're putting these numbers over here, which you can't see. Let me see if I can shrink a little bit. All right, so we're putting these numbers that we pulled for the A, the B, and the C, and we're plugging it into the formula. Okay, so you can use a quadratic equation to really help you find your x-intercept, your zeros, your slope, all of that. All right, so let me keep with the same color palette. So negative b, so my b is 15, plus or minus the square root of b, which is 15, squared, minus 4a, which is 2, c, which is 28, over 2a, and a represents the 2. All right, thank you, Gen X Todd. Thank you so much. I appreciate you coming in. Yep, I'll be here same time tomorrow. Okay. All right, so now let me zoom in a little bit so you can see the graph. All right, so now we're going to solve this. This is the part you have to pay attention to, okay? So it's a negative times a positive 15, okay? So since it's a negative times a positive 15, that means we have x equals negative 15, okay? If I had to substitute a negative, just like how we did up here, we substitute that negative 12, so it's a negative 12 times a negative. That's where the positive 12 came from, okay? We have to watch our signage right from the very beginning. So now we have plus minus the square root, okay, of 15 squared. I think that's 225 if I'm not mistaken. Okay. Minus 4 times 2 gives me 8. And 8 times 28 will give me a 224. Okay. So we're multiplying these three. So if you want to do negative 4 times 2, that gives me a negative 8. And negative 8 times 28 will give me a negative 224. And all of this is over 2 times 2, which gives me 4. Okay, good, Peter. All right. All right. Can you do an A times C method for this? You probably could. You probably could. Now, if I did 28 times 2, that would give me 56. And then I would have to think, what two numbers multiplied together will give me 56 and add together to give me 15? So yes, when you do factoring, there's just multiple ways of getting the same answer. So you can do AC method, especially if it's a number that can break down, but there's going to be times that you can't use AC method. Like you'd be like, I can't get the right combination. That's why the quadratic formula is usually the best one to be used. Okay? So now we have x equals negative 15 plus or minus the square root of 1 over 4. So we know we have negative 15 plus or minus 1, okay, because the square root of 1 is just 1 over 4. So basically they're saying you have like two answers. One of your answers deals with negative 15 plus 1 divided by 4. And your other answer for x is negative 15 minus 1 over 4. That's what that plus minus is doing. Okay, that's exactly what the plus minus is doing. One's going to be adding the two numerators, and the other one's going to be subtracting. So we have negative 15 plus 1, so that will give me a negative 14/4, okay, which could be reduced. Okay, which could be reduced. How did I get 225? 15 squared. 15 times 15 gives me 225. I think that's Diana. Okay. All right. Yep. So this can be reduced by 2. So if I divide that by 2 and divide this by 2, I'm going to get a negative 7/2. It's okay to have improper fractions. But if you're doing any kind of testing, take a look at your answer choices. I know, if you're doing ACT, SAT, GED, Accuplacer, ASVAT, remember, a lot of those exams are multiple choice. So if you can get down one of the sides, you can look at your answer choices and do the process of elimination. All right, so don't forget, that is a huge option. Now, for the other one, we have negative 15 minus 1. That gives me negative 16 divided by 4. Well, negative 16 divided by 4, that gives me a negative 4. So since I have two solutions, okay, I knew ahead of time I was going to have two solutions because of my highest degree. Okay, okay, because of that highest degree. So I have two solutions. So that this graph is crossing the x-axis at -7/2 and also at -4. Okay. All right, -7/2 and at -4. All right. All right. How are we doing? Okay. Do we see why it's not a negative? Or I see an IDK. All right. Okay. So I'm seeing taps. I'm seeing I'm seeing some follows. I'm seeing some shares, which I greatly appreciate. All right. Questions on where did I get certain things? Am I going too fast? Am I going too slow? Talk to me. Well, too slow is, eye of the beholder. Okay. Oh, no problem, Danny. No problem. All right. So let's try another. Because as you can see, these take up a lot of room. Okay. Sometimes this can go even further. Okay. So when you're breaking down, you always want to make sure you have plenty of room. So let's see what we got here. All right, so let's see about one. I'm kind of curious about this one. So we have 6x squared plus 3x minus 18 equals 0. Aw, well, thank you. Probably can. Just a little bit of practice. Oh, I know. Trust me. My brain is completely kaput. Lots of tutoring. Yes, completely. All right. Ooh, Danny is saying that we have a GCF of 3. Okay? So, just for those that weren't here yesterday, or maybe a refresher for everyone else, the first question, anytime they ask you to factor, first thing you should ask yourself, do I have a GCF? If you do, factor that bad boy out. So right now, 6, 3, and 18, they all have, even though it's a negative 18, but since there's operations in between each of the terms, okay, so we have a 3. Not a 3x, because that 18 doesn't have an x. So it's just going to be a 3. So now we're going to take our original equation and divide everything by 3. Okay, what do I get when I divide 6x squared plus 3x minus 18 by 3? Put it in the chat. Okay. Yep, you can divide both sides by 3. But let's factor first. See what's left over. Wait, what? We have a GCF, 6, 3, and 18 has a GCF of 3 in common. So we're factoring that out. So now I'm asking you what's going to remain inside the parenthesis after we factor out the 3. Is that kin? So kin says 2x squared plus x minus 6. Danny says 3x plus x minus 6. And I want to say jeta, or geta, which is 2x squared plus x minus 6. Where did the 3 come from? You factor it out. That's your GCF. That's what 6 and 3 and 18 have in common. All right, Danny went to 2x plus x minus 6. Cookie, hey Cookie. We have 3 times 2x squared plus x minus 6. Oh, okay. And then 333 A Martinez says 2x squared plus x minus 6. MV says 2x squared plus x minus 6. Is it Kiara? Kiara or Kiara? Say my 2x plus 1x minus 6. Okay, 2x squared plus x minus 6, 2x plus 9 plus 6. All right, so let's take a look. So 6 divided by 3 will give me 2, and I bring down the x squared because we don't have any x's out. Now, 3x divided by 3, that gives me a positive 1x, or I could just simply say x. The 1 is understood to be in front of the x. Then we have a negative 18. Negative 18 divided by 3 gives me a negative 6. Okay, good job, you guys. So now, just like how we mentioned yesterday, we always take a look inside of our parenthesis. Okay, so right here, inside the parenthesis, we have 2x squared plus x minus 6. If I were to do the cross, that means I would multiply my a and my c. So I would get 2 times negative 6. That'll give me negative 12. And my b would be a positive 1. So what two numbers multiplied together will give me a negative 12 and added together to give me a 1? So two numbers multiply to give me a negative 12 and add together to give me a 1. Okay. Roxanne says negative 4 and 3. Is it Raul? Saying positive 4 and negative 3? Pog, hey Pog, says 4 and negative 3. Okay. I always like to make sure I get people's name right. Because, you know, there's a pride in the person's name. All right. So if we say 4 and 3, the one that needs to be negative to get me a positive 1 will be a negative 3. Okay? So 6 and negative 2, if I add those together, I will get a positive 4. But I'm looking for a positive 1. Okay. All right. So since we found our middle terms, what I could do, this is AC method, right? What I could do is set up my two ratios, do my 2x, write that out twice, and underneath I'll have 4, and the other one is negative 3. The first ratio can be reduced by 1/2. The second ratio is going to stay exactly the same. So if I wanted to, I could say 3 times x plus 2. and 2x minus 3. You're probably saying, well, Audrey, what happened to the quadratic formula? You could solve by using these. This is your A, the 1 is your B, and negative 6 is your C. You can use that to plug into the quadratic formula. Let me show you, I think. If I can find my pen. Okay. All right. So if I wanted the quadratic formula, I'm going to put it off to the side here because I got to do some work over here. Remember, my x is going to equal my negative b, and my b was 1, plus or minus the square root of my b squared, so that's 1 squared, minus 4 times my a is 2, times my c, which is a negative 6. And all of this is over 2 times my a, which is 2. Okay, so that means a negative times a positive 1 will give me a negative 1 plus or minus square root. All right. Okay, so we could either do AC method because it worked when it comes to the cross, or we can do quadratic formula. I'm showing two ways. Okay, learned it a whole different way. Okay. So 1 times, so we got negative 4 times 2 gives me negative 8. Negative 8 times negative 6 gives me a positive 48. All over 2 times 2, which gives me 4. Okay. So we have our negative 1 plus or minus the square root of 1 plus 48, which gives me 49. Square root of 49 will give me 7. So basically, we have negative 1 plus or minus 7 over 4. So we have two solutions here. The first solution deals with negative 1 plus 7 over 4. And the other solution deals with negative 1 minus 7 over 4. So negative 1 plus 7, that gives me 6. So we have 6/4. 6/4 could be reduced to 3/2. So that's going to be one of our x-intercepts. Okay. Then negative 1 minus 7, that gives you a negative 8. And negative 8 divided by 4, that gives me a negative 2. Let me show you where this can come from when we do it the AC method. We did our factoring, but the part that was missing is we need to set everything equal to 0. Well, we know the first one, 3 cannot equal 0. So we know that's done. But then we have this x plus 2 equals 0. And then we also have this 2x minus 3 equals 0. So what we can do is we can ignore this one because 3 can't equal 0. We know that. Some people like to divide 3 on both sides just to get it out of the way. You can do that as well. Either way, it's just not there. But here, I need to subtract 2. Okay, in order for my x to be by itself, which gives you x is equal to -2. Then the other one, I'm going to add 3 on both sides. That brings down my 2x. But 0 plus 3 gives me 3. Then you would divide both sides by 2, and you would get x is equal to 3/2. Does that sound familiar? Okay, that's what I'm saying. Yes, we're doing all factoring. It's all factoring. This is quadratics. Okay. All right. So when you look at it, there's just 2 ways. You have either the AC method, which came here, but we get the same exact answers. Okay? So either you can do it all in the quadratic formula and find out what your x values, where your graph is going to cross the x-axis, or you can do AC method. Okay? You can do the AC method. All right, you'll take the left side? Yes? So someone said they learned it in a totally different way. I wasn't ignoring you. I just wanted to finish my thought. Yeah, oh yeah, it was a Virgo. A Virgo, how did you, thank you mamas, girls. How did you break it down? If you can remember the name of it, name of the process. So you'll take the left side? Okay. Because there's more than one way to get your answer. All right? So either you can do AC factoring, you can factor out the GCF, divide both sides by 3 if you want to. Then you will focus on what will be your 2 parentheses if you have the AC method. Okay? Yep. I think I have time when I first started college, but the end seems familiar. Okay. Okay. All right, so let's do one more. All right. Let's see if you guys can see what I'm writing. That will be helpful. All right, let's do, oh, almost, we already did that one. Let's do, so many choices. Okay, let's do this one. Let's do 9x squared plus 4x minus 16. So I'm going to put it up top, the formula, so we can definitely keep that in mind. So we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So this is the formula. Okay. Okay. A Virgo? We don't have a GCF. And let me explain why. The only thing that 9, 4, and 16 have in common is 1. Yep. So quadratic formula. Make it pop a little bit more, I think. Okay. All right. Yes. So it's got to be something that all 3 spots have in common. All right. So tell me what my A is, tell me what my B is, and tell me what my C is. Go ahead and put it in the chat. Thank you for sharing the live, Barbara. I appreciate it. So if you guys know of anyone that's thinking about taking the ASVAT, taking the Accuplacer, for them to get into community college, that's thinking about taking their GED, okay, this is definitely the live for them, because the quadratic formula, especially GED, this is a 4-point question. This is money right here. Okay, if you can basically do anything factoring, anything linear or quadratic, and you do some or a good majority of the arithmetic, you'll pass it. Because remember, all the test problems are not graded exactly the same. You have 1-point questions, 2-point, 3-point, 4-point questions, but they won't tell you which one is a 1, 2, 3, or 4. Okay. But because I had so many students take the GED before, a lot of them said it was the anything that dealt with linear functions, volume, and surface area, equation of the line was your 4-point questions. Okay. Good. So A is 9, B is 4, C is negative 16. Good. So now plug it in to your equation, into the formula. Okay, good. So you're taking the GED? Awesome. Why is A 9? Because if I look at standard form is AX squared plus BX plus C. Your A is always what's in front of the X squared. Your B is always what's in front of the X. And the C is always the constant, including the sign. Okay. Well, thank you for the roses. Did it answer your question? Okay. All right. Okay, good. So all we have to do is plug the information into our formula. Let me rewrite this formula in a darker color, just in case you guys can't pick it up. I was trying to highlight it to make it pop a little bit, and I was like, it just blended. You're like, okay. That's not helping anybody. Okay, that makes it pop a little bit more. There we go. Oh, well, thank you, Mama girls. Appreciate that. Yes, anything would be delightful. You know, because I really want to help. My whole premise is to basically attract people that really needs assistance. I'm not trying to be TikTok famous. I don't think I can handle it. Like, I don't know. I don't know if I can handle it. Right. It's so funny because the quadratic formula really gets you to your answers so much quicker than a lot of others. Believe it or not. Yes. Yes. So because my highest degree is to the second power, Bri, or Brie, you are going to get 2 answers. The quadratic will always work, and the reason why I say that is what happens underneath the square root. Okay, I'm not going to do a whole lot with it, but I am going to tell you a little bit. All right, so if we have our formula, we have x equals our negative b plus or minus the square root of our b, which is 4 squared, minus 4 times our a, which is 9, and our c, which is negative 16. And all of that is over 2 times my a, which again is 9. So you're using the b's twice and you're using the a's twice. You're only going to use the c once. Ah, there we go, Danny. That's exactly what I'm about to talk about. All right, so we have our x equals our negative 4 plus or minus 4 squared, that gives me 16, minus, so 4 times 9, that gives me, well, it'll be a negative 4 times 9. That will give me 36, and then multiply that by a negative 16. Okay, so negative 36 times negative 16, that will give me a positive 576. Okay, this minus that's in front of the 4 acts as a negative for just this 4. So a negative times a negative will give me a positive. So 4 times 9 gives me 36, and 36 times 16 gives me 556. Now, let's add that 556. Hey, Bree, how are you? We'll add that 556 with that 16, but let's not forget 2 times 9, which gives me 18. So we got negative 4 plus or minus square root. This gives me 592 over 18. Let me raise it up a little bit or move it down like that. Okay. All right, are we okay so far? Okay, yes. Do we simplify the radical? Yes. Gianna, okay, this is my sign to study. There we go. Now, the square root of 592. So this is something that a lot of students kind of get hooked up on. So let me see. Let me see if I can just use a pencil real quick. As soon as I can pick the pencil up. There we go. All right. So if I have the square root, and I'm going to put it off to the side here, of 592. This can be factored, or at least we try, into 2 radicals. Now, 592, you're probably like, oof, that's pretty large. Like, how am I going to organize all that? Well, why don't we play around? It's either we're going to play around with a perfect by dividing it by a perfect, or we divide it by a prime number. So let's see. Let's see if I can get everything in here. Oops, wrong way. Sorry. All right. So let's see if we can get some numbers going on here. So we have 592. Sometimes I like to divide it by a prime number and see if I get a whole number as my answer. Not sure if y'all can see this. Okay, you can see it this way. So if I divide that 592 by 2, I get 296. So 296, that's not so much of a perfect, but it's not prime. But if I go with 592 and say if I want to divide by, I don't know, it won't be 5, let's say by 6. Obviously, it's going to give me a crazy decimal. All right. Okay. All right. But we're going to play around with a couple of the numbers. Either you want to play around with the prime numbers, or you can play around with some of those perfect squares. So right now, if I look at 2, let me put it this way. If I do 2, and I totally forgot how much it was again. That's how my day is going. So let me see. 296. Okay. I'm going to see if I can break down this 296 by 2, which I do. So it's telling me that I got like a perfect square in there. So if I do 296 divided by 16, let me see. Oh, that gives me a decimal. If I do 296 divided by 81, oh, that's a decimal. If I do, well, I did 295. 296, let's try that again. Again, it'll be a decimal. But if I want to keep going by 2s, eventually I'll get it. But again, this is a time test, right? So 296, if I divide by 4, I get 74. Okay. All right. So far I got a 2, I got a 4. Now 74, if I divide by 2, I get a 37. I'm going to just show you what's going to happen here. Now 37, that's prime. That's definitely prime. So here's the trick. 2 times 4 times 2. 2 times 4 gives me 8. 8 times 2 gives me 16. So if I go back to my original 592 and I divide it by 16, I'm going to get my 32. So the square root of 592 is actually going to be the square root of 16 divided by the square root of 37. Square root of 16 gives me 4. I know, it looks all kinds of crazy as soon as I can get everything on there. Okay. Right? Because remember, email, you can break down that 74. You just had to take one more step. Yes, Nicole, that's what happens when you're dealing with larger numbers. You're going to have to do trial and error sometimes. So this is one of those questions that if you get the other ones so quickly, you can spend time on questions like this. Okay? So what's going here is x equals -4 plus or minus 4 square root of 37 over 18. We're almost done. Now, take a look. 4, 4, and 18. Math gives you anxiety. Yes, and I know, Gianna, you said it earlier, so thank you. 16 and 37 does make sense. Sorry, I didn't look up quick enough. All right. So, and then I think it was Bride that said it as well. Actually, you said it before Gianna. Let me see if anyone said it before you. Nope. It was Bri. Or Bree. Okay. The 16 and 37. And then Gianna said 16 and 37. Okay. Okay. All right. 4s and 18s can be reduced by 2s. Okay, not by 4, because 4s don't go into 18, or 18 is going 4s. So this divided by 2 will turn into a negative 2. 4 divided by 2 will turn into a 2. And 18 divided by 2 will turn into a 9. Okay, so we have 2 answers. One answer will be negative 2 plus 2 the square root of 37 over 9. And you can leave it like this. Okay, that's perfectly fine. Your other answer is negative 2 minus 2 square root of 37 over 9. So that was a hoot. You have this as one of your solutions, and this is one of your solutions. Okay. The factor tree, yes. So it's really getting down to our multiplications and trying out a lot of either our prime numbers and keep dividing it by prime numbers, or using our perfects. Sometimes I switch it around. So breaking down with the factor tree sometimes helps. But if sometimes this is a calculator section question. All right. All right, thank you so much for the follow. Thank you for the taps and everything. Appreciate it. Now, someone mentioned, who was it that mentioned? Danny, what if it's a negative underneath the square root? Okay. I am going to fit that in. I'm going to slide this over. I'm just going to fit this in right in this step section. Because when you have a negative underneath your square root, that's called a complex number or an imaginary number. Okay. So you're going to be dealing with something called, are you ready? The letter I. Yes, people, the letter I is actually a number, just like how the letter E is actually a number. Okay, so what if your equation is not equal to 0? You have to make it equal to 0 before you factor. So if it's like equal to 4, that means you need to subtract 4 on both sides before you go into factoring. Okay. No, we do not have to simplify the fraction. No. Yep, that was it. Okay. So, with complex numbers, like if I said the square root of -4. Okay. The square root of -4, that can be factored. The one thing you want to factor out is always your perfect, which is 4, but not so much your prime, but your negative. Because 4 times negative 1 gives me negative 4. So if I factor out the square root of negative 1, now I could focus on the perfect, or the breakdown of this radical. So this square root of 4 gives me 2, and the square root of negative 1 is I. Multiply those two together, you'll get 2I. Yep, I is a number. Who says you don't learn anything on TikTok? Yes, I is a number. Yep. It represents the square root of negative 1. So these are what's called complex numbers. Okay? So we have rational numbers, irrational numbers, and then complex numbers, or some people like to call them imaginary numbers. Okay? All right. So if I said, let's put another example up here. So if I said the square root of negative 72, okay, if I had the square root of negative 72, the first thing I would do is turn that 72 to a positive square root of 72. Okay. But 72 is not a perfect square, but it can be divisible by a perfect square. Okay, what two numbers, perfect prime combination, multiplied will give me 72? Okay. So if we're not sure, here we go. My handy dandy. So we're looking at 72. So here's 72. So we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Now, 9 is perfect, but 8's not prime. So that's not the perfect prime combination. Meanwhile, I can break down that square root of 8 some more. So the perfect prime combination will be 36 and 2. Because the square root of 36 gives me what? You can put it in the chat. Square root of 36 will give me what? Good, Logan. Good. Good, Nicole. Good, Lorena. Lorena. There we go. Good, Cookie. All right. So that means if I come back over here, oops, so much stuff on my desk. All right, organize myself. So I have the square root of 36, the square root of 2, and the square root of negative 1. Square root of 36 will give me 6. Square root of 2, since that's prime, that will just stay the square root of 2. But the square root of negative 1, that is I. Okay. So the square root of negative 1 is always I. Okay. Okay, we're going to talk more about how to basically do operations with complex numbers. So tomorrow we're going to be working on completing the square. That's going to be fun. And then after that, we're going to be working more with complex numbers. But it's always kind of nice to know about complex numbers, especially when you're dealing with the quadratic formula, because you have what happens underneath the square root, which is called your discriminant. Okay, have you guys heard of the discriminant before? So the discriminant kind of tells you what type of solutions you're going to have. So if you notice, the discriminant is b squared minus 4ac. Oh, guess what? It's the same as what's underneath the radical. So what's underneath the radical will tell you what type of solutions you're going to get. Are you going to get one of those double zeros? Are you going to get like two official answers? Or are you going to get a complex number? So like example number 1, underneath the square root, we got 144 minus 144, which gave us 0. So if it equals 0, if the discriminant is equal 0, that means I'm going to have a double zero, in which we did. We had that double zero of 3 halves. Then, underneath this radical, we had 225 minus 224, which gives me 1. The square root of 1 gave me a positive 1. So if it gives me a positive answer, I'm going to have 2 real solutions, which we do. Okay, negative 7 halves, that's a real solution. And negative 4, that's a real solution. Okay, what's the no? No? No for what? What's the no? Nicole? Okay, I know, it's blowing your mind. Okay, so that discriminant tells you a lot of what's going on. Right. Even with the long one underneath the square root, we got a positive 592. That means we're going to have 2 real answers. Although we have square roots in there, it's still a real answer. If I plugged it in, I'll get one of those fun little decimals. Okay. All right. Okay, so about the discriminant question. Oh, okay. Okay. All righty. So I'm going to wrap up because I feel like I'm about to pass out. I'm starting to get the shakes. So, with the quadratic formula, we just basically have our negative b plus or minus the square root of b squared minus 4ac all over 2a. Once you figure out what your a, b, and your c is, you're basically going to plug it in to the formula. If your discriminant is a 0, you're going to have one real solution as a double zero. If your discriminant is positive, you're going to have 2 real solutions. And if your discriminant is what's underneath the square root is negative, you're going to have what's called a complex number. Okay, you're going to have imaginary solutions. That means it's not crossing the x-axis at all. All right. All right. Yes. So tap for a little bit. If I can get to 12, that would be amazing. Hey, good evening to you. All right. Thank you for the roses. I appreciate it. Okay. So if you like the structure of this notebook, I actually designed this as well as resources that can help you out, like this factor sheet that we just used from 1 to 200. So with this, we have other references like adding, subtracting integers and multiplying, dividing. Like what are those rules that we need to understand and keep in mind when we're solving. Also, the most common words used in word problems to help us add, subtract, multiply, divide, equals, and also inequalities. Then we also have, which we were working on today, we kind of mentioned this standard form. Okay, so we talked about standard form and we talked about the quadratic formula. So it just kind of gives you a lot of the resources to help you remember certain tasks, as well as our volume. Okay, we got volume, we got surface area, we have area of sector, the sector, and also the arc length, especially when you get to more advanced math. Then Pythagorean's theorem, and also we're looking at SOHCAHTOA. So this book is actually designed from like 7th grade up to adults. So by using the sheets, you can have one side breaking down concepts, and you can also do some graphing, and then you can work on, like, if you have any kind of formulas and maybe some steps that you need to remember to take all to the side, you can do that. All right. So with all this said and done, you can either take examples from your notes, from the teacher given notes, and tape them in, or you can actually draw your own graphs. But we all know sometimes graphs get a little bit wonky, so it just gets a little tiresome. But instead of you drawing your own graphs, you can just copy and paste the papers inside. Maybe there is like something that your teacher wants you to understand, and you can tape that paper on one side of the book, and then the other side you can summarize what's on that paper. So if you have open notes quizzes, you'll be able to get to your answers so much quicker. All right. Are you going to go over anything involving logs and exponentials? No, I did logs and exponentials, I want to say a week and a half ago to 2 weeks. So that should be in my YouTube channel. Speaking of which, if you can do me a huge favor, okay, since you guys are getting a lot of information for free, if anything, help me out. Help me to get more like paid clients, or maybe you yourself need help with your GED, or maybe you're taking a current class and you just need some assistance or someone to clarify what's going on. Please do not hesitate. Reach out. Put me in the DMs, whatever you want to do. All right. Reach out and just ask, like, hey, Audrey, do you have any spots open? How much is it? What's it like? All that. Okay. So the only way you're going to know and get the help that you need is for you to voice it. All right. Okay, cool. So if anything, if you can, subscribe to my YouTube channel. So my YouTube channel is at Audrey Codner, ACG Math Tutoring. Even if you just type in Audrey Codner, I'm going to pop up. I may pop up under like 3 or 4 other, because I have other sites as well. But go to the one that says ACG Math Tutoring. My replays of all my lives are on my YouTube channel. So if there is something, not just because you came late today, but more so, hey, what does she talk about? Like, did she ever mention this? Did she ever talk about slope? Did she ever talk about equation of a line? Oh, did she talk a little bit about probability? Go and take a look at my videos, okay? So, and also subscribe. It's free. It's cheap. That's all you gotta do, all right? And then all this week, I will be here live at 9:30. The only day not at 9:30 is on Friday. That'll be at 1 p.m. Eastern Standard Time. Saturday and Sunday, I will be here at 8:30 as opposed to 9:30. Okay? All right. Can you tutor my kiddos? We do homeschool. I'm not good at math. Sure. If they're willing to pay attention, and I'm more than willing to do that. So, I mean, I think homeschoolers, you guys are also working through the summer as well. So, yeah, definitely DM me. Definitely DM me, and let's see what we can do, okay? All right, Amy. No problem, Amy. Okay. All right. Okay. So no problem. Definitely. So do not hesitate, because now is a great time. Yeah, I'm getting a little busy, but at the same time, a lot of my students are seniors. So they're graduating and they're taking their final exams earlier than most. So I know I'm going to have some slots opening up. But if one to one, if you would rather have, like, let's do this because I have a couple of people doing this. Like, if you want some on-demand videos that I created, I do have a course for GED, Accuplacer, ASVAT, and also for just algebra in general. So what we can do is you can watch the videos yourself, maybe take notes of the ones that you really want me to work with you one-to-one with, and then we can do a tutoring session that way. So there's possibilities, because I know everyone's schedule is all over the place. And I get it, it's hard because some people have their homeschool schedules, some people are working during the day, some people are nurses and they're trying to, improve by taking the TEAS test, but yet you're working at a place that requires you to be there at like 5:30 in the morning, and I'm not available at 5:30 in the morning. I'm up, but I'm not available. But then sometimes you might be available at 1 o'clock in the morning, and I might be just going to the gym. So it's all kinds of all over the place. Okay. All right. So think about it. Reach out whatever you need. And then here are a couple of people that, if you are thinking about going into nursing and you need someone to help you with your dosage calculation, go follow a blessed RN. She's amazing with it. If you need someone else to help you with TEAS, ASVAT, GED, okay, even Accuplacer, you can follow my friend at Impact Math 19. Okay, she usually goes live Monday through Thursday, if I'm saying that correctly, at 1 p.m. Central Time, which is 2 p.m. Eastern. And if you're looking for a chemistry tutor, Professor TK is really good. She goes live at 10 a.m. Eastern Standard Time. And then my friend Lynette, she teaches kids, and this will be something awesome for you. I don't know how young your kids are, and even adults, anyone that's interested in adding, subtracting, multiplying, or dividing with the abacus. Like, actually learn number placements through the abacus. I have seen students just flourish just by learning how and what the representation of the numbers mean by the use of the abacus. You can take a look and follow my friend Learning with Nanette. She is awesome with that. Hey, Janice, how are you? Hopefully everything's going well with you. Okay, we definitely have to meet up soon, my dear. Just making sure, okay? All right, so I'm actually going to wrap up so I can, 1, download this live, 2, clean up after my lovely dinner, and 3, get my butt ready to go to the gym so I can hit the massage chairs after I'm done. That's the joy. That's the little bit of joy that I have. All right, so not a problem. Yes, not a problem. So have a good night. If you ever have any questions, please don't hesitate to ask. Just go ahead and DM me. I will try to follow as many people as I can. And I know sometimes it gets a bit much at the end. And all right, awesome. Oh, 19.5. Can we make it an even 20? I know I'm being really, really selfish right now. Oh, I didn't even say hello to Tilted Halo. I am so terrible. You can tell I'm tired. I am so tired. Kiddly winks. Love that. How are you? How are you doing, Tilted Halo? Hopefully you're doing okay. I know. I saw you sneaking in here for a little bit. She's like, I tried to just sneak in here. That's fine. That's perfect. I appreciate it. Oh, perfect. That's awesome. All right. Not a problem. That's perfect. I'm not selfish. This is perfectly fine for me. All right. Thank you so much, guys. Thank you so much. And yes, God is good. Where have you been? How are you? It's been a minute. All right. So have a lovely evening, guys, and I will see you tomorrow night at 9:30. I will definitely not be coming early because I'll be literally running right from a tutoring session to come on live. All right. So I will see you tomorrow night. Have a lovely evening, afternoon, and morning, and continue to be the awesome people that you are. The world needs you. The world needs you. Okay. All right. Take care. Bye now.